This is question number 2 from the 2015 Chaos examination paper. 2a, we're given this iterative formula for the propagation of light through optical fibre. It's given by the Ikeda mapping. And we want to determine the fixed points of period 1 when A is 1 and B is 0.7. Remember, A is related to input and B is the fibre coupling ratio. For part B, we want to find the fixed points of periods 1 and 2 for this complex iterative map and determine the stability of fixed points of period 1. So for part A, we have en plus 1 is A plus B en e to the I mod en squared. We can split this into real and imaginary parts because we know that en is xn plus I yn. So we just simply split this into real and imaginary parts and we get these two iterative formulae. To determine the fixed points of period 1, we suppose that we assume that xn plus 1 is the same as xn, and then we call it xsay, and yn plus 1 equals yn, and we call it ysay. So we get simultaneous equations. So here are the simultaneous equations in x and y. And remember, en mod en squared is just x squared plus y squared. So if we substitute those into MATLAB and use EasyPlot, and you can find the program in the notes or download it from the web, then this is the picture we get, and you can see that there are 3 intersections and we use the data cursor to find these intersections. So there are 3 fixed points at period 1 and these are the approximate points which you can check yourself. So for part B, we want to determine the fixed points of period 1 for this mapping. So again, we assume that Zn plus 1 equals Zn, call it Zsay. We get this simple quadratic formula. We use MATLAB to solve this quadratic equation, and then we use VPA to put it into the form x plus iy. So here are our 2 fixed points of period 1. These are wrong here. We should have the modulus of 2z11 and the modulus of 2z12 because we want the modulus of f dashed z, which in this case is 2z. So that should be 2z12 and 2z11. And in any case, the modulus of both of those is bigger than 1, so both points are unstable. To find the fixed points of period 2, we want to know when does Zn plus 2 equal Zn equals z. So just using simple iterative formula, we now get a quartic equation. So here is the quartic equation. Again, we can solve this with MATLAB. Now in the examination, you will know if you're correct or incorrect because there are 4 roots. 2 of the roots are Z11 and Z12 and the others are Z21 and Z22. So you will know if you're correct or not because these should appear when you solve this equation because the fixed points of period 1 are also period 2. And that concludes the solutions to question number 2.